Hello guys, this is Phys103. This is on nuclear physics, and in this lesson we are going to learn about alpha decay. So last lesson we introduced the Segre chart, wherein it tells you in the x-axis the number of protons, z, and in the y-axis the number of neutrons. So a 45-degree line would tell you that the number of neutrons is equal to the number of protons. So this line tells you that the nucleus is stable. So inside this chart is plotted different nucleides of different elements. So as you go further up the periodic table, we have learned that only in this region we have stable nuclei, and in this region we have unstable. Actually, about not this region, maybe even just this region, where n equals z. So one thing that the nucleus can do is to reduce its protons and neutrons. So if the nucleus reduces its proton number, it can go into this area wherein it is more stable. So it can do so by alpha decay. So what is alpha decay? So it's a nuclear decay wherein you have alpha particles. So alpha particles are basically alpha particles are helium nuclei. So by releasing helium nuclei, this original element, so we say element X, which has Z protons and mass number of A, this is called the parent nuclei. It can reduce its mass number by 4 and its proton count by 2, given it releases this alpha particle. So the alpha particle has two protons and 2 neutrons. So this is the parent, this is the daughter nuclei. So now we ask when does alpha decay occur? So alpha decay can occur given that the element is way in here in the Segre chart. So atoms would always want to stabilize their nuclei. So they could go into releasing alpha particle so that their proton number and their neutron number would decrease. So in terms of their masses, so the parent nuclei should weighs heavier compared to the sum of these two masses. So for example, let's say that this has, I don't know, maybe 3 atomic mass units. the daughter nuclei only has, this is two, let's say 13 atomic mass units, because this should have 4 atomic mass units. So this is 4 atomic mass units, and this is 13 minus 4, 9 atomic mass units. So by conservation of mass, this should happen, but the way we observe alpha decay is that they do not happen. So the combined product of the daughter particle and the alpha particle, it weighs less than the parent. So where did the mass go? So the mass was converted to energy, particularly kinetic energy. So that's why when an unstable nuclei emits a alpha particle, the alpha particle travels very fast. So that velocity of the particle is due to the mass defect it went when the parent particle released the parent nuclei, when the parent nuclei released the alpha particle.